Have you ever wondered why cold air flows out of your refrigerator and sinks to the floor? Or why smoke from a fire rises into the sky? Today, we are conducting an experiment using a convection box to visualize invisible air movements. Hi guys, I'm Berra. Today I'm going to do convection box experiments. A convection box demonstrates convection currents and temperature inversions. So when air is heated up, its molecules speed up and spread out, making it less dense than the surrounding air. This causes warm air to rise while cooler air to sink. This cycle is convection current. However, sometimes warm air moves over cooler air and traps it, and this is known as temperature inversion. This experiment demonstrates both phenomena. I'll be simulating convection currents. For this experiment, I have cardboard tubes as chimney, a candle, a long match, and paper towel. And now I light a paper towel, blow it out to create smoke, and hold it over the unheated chimney. To make the air movement visible, I'm introducing smoke into the unheated chimney. Watch closely. Notice how the smoke is pulled into the box. Inside, it warms up, rises, and exits through the chimney above the candle. This flow is a convection current. It mimics global wind patterns where warm air from the equator rises and moves toward the poles. For the next experiment, I have chimneys, an index card, paper towels, match, and bags of ice cubes. Let's start the experiment. Now we are moving on to the most critical part of the experiment, the temperature inversion. Under normal atmospheric conditions, air temperature decreases as you go higher. This allows warm, polluted air from the ground to rise and disperse. But sometimes nature flips the script. In this box, we are simulating that exact inverted condition. Here is what I've done. I placed bags of ice at the bottom of the box to drastically cool the air near the ground. I'm using this long match to create a layer of warm air sitting right on top. Physics tells us that cold air molecules are packed close together, making cold air denser and heavier. Warm air, on the other hand, expands and becomes less dense and buoyant. So right now we have heavy air sitting at the bottom, being held down by a layer of lighter, warm air. Now let's introduce the smoke and watch what happens. The smoke tries to rise, but it can't. It spreads out along the bottom of the box as if it's an invisible ceiling. This happens because the cool air at the bottom is too dense to rise through the warm layer above it. The warm air acts like a lid or blanket, completely stopping the vertical air movement. The natural convection current we saw earlier has been shut down. In summary, when warm air moves over cold air, it traps pollutants at the surface, creating a temperature inversion. So let's move on to the answering some questions. Question 1 is, what's a convection current? A convection current is a cyclic behavior of air sinking and rising due to differences in density. Question 2, what's the temperature inversion? A temperature inversion is a situation that occurs when warm air moves over cool air and traps it. Number 3, why do you think that smoking paper towels were used in this experiment? The smoke produced by paper towel made it possible to see the air movements. Question 4, what happened to the smoke in convection simulation? The smoke was pulled into the box through the unheated chimney. In the box, the smoky air warmed up and rose out of the chimney containing candle. Question 5. What happened to the smoke in inversion simulation? The smoke was trapped at the bottom of the shoebox. Because the cold air was denser than the warm air, the air could not rise, simulating trapped pollution. So this was it for today. Thank you for watching. Bye bye.